Hey there, you're going to learn something really important. So when you have a chess game like this, you can move this pawn, then move the rook up there, and then you move your queen up there, and checkmate. So this is a variant of the shepherd's mate, coup du berger. I'm sure most of you knew about it already, but what you're gonna learn is how to build this chess game with really few lines of Datastar, and you're going to see all the benefits of building a game the Datastar way. This video will go and take from the topics from the two previous videos, so go watch them if you haven't. And well, how does that work? You see, we have a surprising amount of interactivity. So we can hover some squares. When I click something, it goes red. Let me launch another game to show you that when I click on a piece, you have the possible squares that you can get to. You have an indication for when the opponent is thinking right there. So yeah, you have a surprising amount of logic, of interactivity, and it's actually very, very simple to do. Let me show you how we are going to do this by first showing you a drawing. So what's happening is that we are going to try to put as much stuff into our server as possible. We will register the events in the server. We will create the view, the HTML view in the server. We will do all logic in the server. What happens when a player launches a game? We open a connection. So as with Datastar, you want to open a long-lived SSE connection to stream down what is happening in the game. And by this connection, we will create the HTML of the board, and we will register another route where the user clicked, and we try to process some moves and create the corresponding HTML and send it down to the players. So we don't want to do polling. We have an open connection, there's no need for polling. So what we are going to use is a publish and subscribe system. Basically, we subscribe the players to the events happening in this room. Events happening in this room, for example, can be well, a move was made, so there's a new state, and whenever something happened in the channel, they receive a message because they are subscribed to it. We push a message to the channel, they receive it, and well, then they get the corresponding HTML view that they want. We will just register with one route where the user clicked, and we will return them the corresponding HTML after our calculations. It is really that simple of a data model. It's really, really simple. Let's try to have a look at the HTML before diving into the code. So we can open DevTools right there. We see we have a main section with some UI elements. So you have here the name of the room, you have here the name of the players, if they are thinking and stuff, just like there. You might be wondering, so how do we construct the HTML? It's actually fairly easy to see. We are going to create a main element with some UI stuff, the name of the room, name of the players, stuff like that, and Then we create the chessboard, which is just like an 8x8 grid. Really easy to do in CSS as well, and because it's in CSS, we have some nice features like hovering over an element, giving it a slightly darker shade, stuff like that. It's really easy to do with CSS, and you can check the code to see how it's done. And then we place the pieces where we want them to be, and this is really easy to do because we can just save a list, the list of pieces and their position. We can save a string representing all the pieces position. This is actually called the fence state, so it's implemented everywhere. I will show you what it looks like. So yeah, a fence state is just this. It's just the list of a string with all the squares in order and if there's a piece on them or not. Plus some additional information like whose turn is it to play, can we castle or stuff like that. So my room was called brown. Let's see, brown. Can I see the brown room? Yeah, we see here we have the history of the fence state of this room. It always starts the same because it's the starting position of the game, and then we are recording every modification to the fence state. And so we can reconstruct at any point in time, for example, what was the board like one move before. So if you want to add something like an undo button to undo a move, well, you would just query the fence state that was before and create the corresponding view and send it to the user. Really simple stuff to do. What was my name? Richard Brown, and Richard Brown is here, and you can see the other stuff I'm saving is all the clicks that were made by Richard Brown. So we have we save it as a Redis list, so the last click is here and the first click I ever did was here, and every time I register which square the user clicked. Let's see how we construct our view. As we said, so the chessboard position is fully encoded in a fence state, so we only need this to create our chessboard. We are going to use chess here as our chess engine, which is really good because we can get the list of legal moves. We don't have to compute them. We have a generator in this library. And for this, for all legal moves, we're going to hard encode them. We are going to say, well, here's my list of what can goes where. Then we have the chessboard, and the first instance of Datastar that you are going to see is that we are declaring a signal. The signal we are declaring is clicked. We add if missing. We haven't seen that already because we are going to return the chessboard a lot. We're going to return it in every view we generate. We don't want the clicked signal to be erased every time. So we just add if missing so that in the first iteration when we send the view and we haven't set up the signal yet, it's -1, so it's like a default value. And then for the interactivity part, it's not gonna be in this, it's gonna be in main. What we are doing is, well, if I click outside the chessboard, we have another modifier like this. We can put click back to a default value of -1. So that way you can have this stuff when you click to select a piece, but then when you click outside, it deselects. So you already saw we do this trick. So everything was pre-computed, but how do those two squares manage to light up when I click on this? Once again, because you are pre-computing a lot of stuff, for every square that you are going to compute, so you will give them some attributes, data attributes. So we are going to set up a lot of data attributes. We're not going to use this one, but for example, the clicked attribute, which will light up the square in green, is a conditional attribute, and it is if the clicked value is equal to the value of the square. Of course, we are going to add for every of this square data on clicked equals square. Let me rephrase that. We only have one scenario, which is what square is clicked. The way we do this with Datastar is very simple. We just put data on clicked and clicked equals square. So here the value of square will be dynamically generated when we iterate over the square in the board on our backend. So this way we can make sure that clicked has some predefined attributes, and because of the reactive nature of Datastar, then we can link other behavior to this signal clicked. So for example, we have pre-computed all of our possible square values, and we say, well, this is the list of pieces that can go to me as a square, and so if clicked is inside a list, then I'm a valid destination square. This part is a bit tricky, but there's no magic to it. This is like perfectly valid JavaScript, and well, alright, so this is how you create your chessboard. You only need the fence state, and then you hook up some reactive signals and reactive behavior to it with Datastar. It's really easy. I mean, you do most of the hard computing part in your backend, and the reactivity is battery is included with Datastar. So this is really nice, and this is how we do the chessboard. Let's see now the rest of the view. So for a view, we are going to need a bit more information: the board name, the fence state, because we are going to call a chessboard function, the name of the players, if the opponent is thinking, if the game is over, stuff like that. You can see here we're gonna time our functions, and you will see that this is really fast. Actually, I can show you now. Let me check. So view function, a view function is like in the milliseconds. A view function, creating this HTML is like really a matter of milliseconds. It's really not computationally expensive. We are not creating strings and appending to them. Once again, try to use your own HTML generator, whatever way you think is best. This is another way. You can just put the parts in a list and then call join at the end of the view function. You do you, I mean. So, back to the Datastar stuff, which is more important. You can see that on the main we have this function, which will be the heart of the application. Data on signals change. Whenever a signal change, we will issue a post request to chess, the chess route. We only have one signal, so that means that whenever the user clicks on a square, the value of clicked signal in the chessboard gets updated, and the main element can see that and issue post request to chess. And because the post request will include the value of all signals in the request, then we can get back easily what was the value that of the square that the user clicked. So yeah, really simple stuff. We put the board name. I'm not sure there's really much stuff to discuss about here. If there's a game over message, we put it. If the opponent is thinking, we put it, and we await from the chessboard and we put it. Really simple stuff, but it's time to go into the logic of the application. So this is how we generated the HTML. We want to open a connection. What we are going to do is on our index, just render a simple template, index.html. And as you can see, this is just one button. And if you take a look at the HTML, this button has data on click and issues a get request to new game. And this is where we are going to open our long-lasting connection. By the way, don't forget to get Datastar. Maybe I should have precised this is like beta 9 version. Maybe there will be some changes. So yeah, we return in the index page, we load the Datastar for the user, and we say whenever you're ready, just click on new game and we will open a session for you. What is happening in this connection? So we create a board name, so we give it like for example a color name. See, medium spring green, thanks to Faker. We put the name in the session, and then we are going to do some stuff with Redis, which we use as our primary database. We are going to push the starting fan string on a special key, which will be related to the board name. So make sure you don't have conflicting board names here. We are going to push a value onto the move user with the username, so that we can start registering wherever he clicks. We use a pipeline from Redis to batch these commands. We log this, and here's the interesting part. We subscribe the user to the board name. So now the user is subscribed to this channel board name, and whenever there is something pushed, we can wait for it and get the message associated with it. We build our generator, so the function that will run indefinitely for the length of the connection. We use a try block to be able to do some stuff on disconnect, and we just wait for messages. So it's really simple. You just wait for messages right there. If there's a message, you can decide what to do based on what was the information that was given to you, and you will see we have some. We can, for example, react to a message about game over, in which case we will update the game over data. We can react to a message saying that someone played, in which case we can also call functions, react to it. I mean, when you have this setup where you are just waiting for messages on a long-lasting connection, then you can do whatever you want. You can stream down the type of event you want and act how you want on it, so it's really powerful. What we do is when we have a message, we assume something has changed. So as the other very important part, we are going to check the fence state of the board, make the view, and use merge fragments to merge the view thanks to Datastar. So we are using idiomorph, I guess. Yeah. So don't forget to put the ID on main. We are just merging on main, so it's really not a problem. And well, if a user cancels out, we can subscribe it from the channel because we don't want to clutter it too much. So yeah, really, really simple. And then this is the answer we get. So that's the thing I wanted to talk about. That's the way to do it. I guess I'll now talk about the chess logic for a minute, and then we'll see. We'll talk about the benefits of doing it that way, because the chess logic isn't really that fun, but so let's go into it. So very simple, the famous chess road that gets called on every signal change. We await for the data signals data with the request, so sent as a JSON body because it is a post request. I'm going to go a bit faster here. We get the click signal, we retrieve the fence state, and we try to see if the user is allowed to play at this moment. If he's allowed to play, when we are going to check the list of clicks that he did. So here you can see all the list of click square. So we just take the value of the last 2 clicks he did and see if that represents a valid move. So really, really simple. We take the last 2 clicks and see if it is a valid move. If it is a valid move, well, we have a new fence state, we registered a new fence state, and then we publish to the channel with the board name that someone played. So put some stuff, make the new view. We use asyncio to create a task to make the AI make a move. So the AI is just choosing a move at random, but because we use create task, the task is immediately, we're not awaiting it, it is immediately created and run in the main loop. That's about it. That's about it, really. Let's see. Yeah, the try move for the user. Yeah, if move in legal moves, we push the move to the board, and we push the new fan state, and we check for game result. If there's a checkmate or stuff like this. If there's a checkmate, we publish it to the client. So you see, you can publish about almost about anything, and let the root decide how to handle its messages. But the routes are defined in your backend, and that's the nice stuff. The AM with just, yeah, going to read from the current fan state and choosing a move at random. It's actually, everything is like really fast. With a simulated delay of 2 seconds, so we give the impression that the AI is thinking for a bit, but yeah, I mean, there's not much to it, because build your own game and you will have your own way to say this. Let's take a last look at what we have in the database. So yeah, you see, look, all right, let me flush the DB, start a new game, and we will recap what we learned. So when I click on the chess button, I open a long-lived SSE connection. We see here that our name is Richard Brown and the room is medium turquoise. If we go to the database, refresh it, we see that we have created 2 entries in our Redis database. The list of squares I clicked, so I didn't click anything yet, but for the computation of the last 2 clicks, we have this default value of -1 and the fan state of the board. For example, then I can click on this, and you see here that they were all registered here. So I clicked on squares 8, 9, 10, 11, 12. Everything was registered. Everything was properly computed, because every time I clicked on something, the backend took the last 2 clicks I did and checked if it was a valid move, if it was my turn to play. But even if it wasn't my turn to play, I mean, the backend handled that logic, but for the audits of what I did or what I didn't, I have all the clicks I ever did here. If I click outside and reset the value of clicked, well, the signal changed, and you see that we have also registered that. So people playing your game will not be able to accuse you of spaghetti code or misclicks. It's like not possible anymore. And let's try to change the fan state, because you see it hasn't moved. I move my pawn up here, and the fan state has changed. One time because I played and it was no the AI turned to play, and the second time because the AI played. And every time I know in my logic that every time that the fan state was updated, there was a publication in a channel, and people subscribed to that channel and received the latest fan state that we have in the backend. So let's wrap up on the 3 main benefits, and you will see that it is like the holy trinity of programming, and this is really why you want Datastar for your projects. First, it's fast, like really fast. The reactivity thanks to Datastar is like instant speed. I can click this, click that. I'm never worried about performance issues because it's all reactive and the signals are handling it really good. The database writing and reading stuff, because we use Redis and we just read from well-defined data models, not a problem, really fast. Creating the view, creating the HTML is lightning fast as well. Yeah, I mean, it's like responding to a click or an event is a few milliseconds every time. Creating the view is barely a problem. Responding to the routes or handling everything that happened. Where is the click? Should we change the state? Should we put, I mean, we don't change the state, we just put entries in databases and then perform some checks and react to it and publish to some channels. There's like no magic to it, and it's still a few milliseconds, so nothing, really nothing. You will see in the link below the demo is online, you can trade even on a real server, no problem at all, really fast. So first benefit, you're gonna make a really fast app and loading times are 0 because you don't import anything. Second benefit, and it is really important, it is simple. The whole game is just driven with like one signal. You just register the stuff, the signal handles the front-end reactivity, the convey some information to the backend. We just have to register the right stuff. It's really, really, really simple. So fast, simple. And the third one is that it is reliable. And I wanted to show you something. Let's take a look at Hikaru playing Kung Fu chess. So chess in real time. The idea is that you can move your pieces when you want, but you must wait like 30 seconds before moving them again. I will show you an extract of this video right now.
Yeah, it didn't let me play en passant. They're trying to understand how it's supposed to work, though.
All right, so as you can see, you have some timer here on the piece that indicates when you can move them or not. But let's try to imagine if we were going to do this on a PvP server, so you can play one against each other. This is like a case for reliability, because you really want your backend to drive the state. You don't want, for example, somebody who has a faster computer to have decreasing signals faster, or being able to move a piece that you thought you had disabled. So you really want a tight control on the auditability of what you are registering. And I mean, I think it's a great use case for Datastar as well, because you can use the fragment merging for I mean, just like did for the state of the board of the game. You can use the signals to display some information about the time that's left before you can move piece. You can even use execute script, so you can have the nice sound effects and music with it. I mean, we could add some effects, sound effects to the game and the demo right now as well. So try to embrace this method of building apps, I guess. Yeah, back to the game. I could add sound effects. Initially I wanted to like do Kung Fu chess all the way, but well, it's not my favorite flavor chess. I invented a game. I think it didn't exist, which I call fish chess, where the pawns can eat up front. So for example, here I could eat this knight if I wanted, but I couldn't eat this pawn. So it's really the pawns eat up front. This is what I plan to do with the demo next. But please tell me in the comments if you want to see fish chess or if you want to see Kung Fu chess next. Don't forget that you have to build. You have to use DS and build. And let me know in the comments. I will put the source code in the comments as well, the link to the live demo, the link to Datastar, but I hope that you saw the previous videos so that you are already familiar. If not and you have watched all this video, go watch the other ones and go build with it. Drop in the comments what you build with it. Join the Discord and whatnot, and that's about it. See you there.